Hello, welcome back to the channel. So let's do one more question on integration by parts. But in this video, in this specific example, we have more than two functions. You remember when we used to do integration by parts in the previous videos, we either had one function or two functions at max, right? But in this video, we have indeed three combination of functions, right? We have x, we have e to the power minus x, and we also have 1 by 1 minus x to the power whole square, right? So in this video, we'll realize how we can solve these type of indefinite integrals easily when we have more than two functions, and also we have to use the integration by parts in order to solve these type of questions, right? So before we dive into this video, I would highly suggest you to first watch my previous videos on the integration by parts in order to get the full idea about what we will be discussing in this video for solving this example over here. So when we did the integration by parts video before, we had to assume our two functions over here, right? And in this case as well, we'll take two functions only, but since in this case we have three functions, so we'll have to take a package of two functions and then one function separately, right? And in this case, before you combine those two functions together in order to form your first function and second function, you'll have to consider one important fact, that you have to basically simplify this expression over here, right? Because you're already calculating an indefinite integral for this whole expression, so you want the final indefinite integral to be simpler than your original question expression, right? So that is why whenever you're choosing your first function and second function, in this case, you have to make sure that this expression is simplified to a simpler expression than the original expression in this case. And for doing that, you'll have to basically go through all the possible combinations in order to check which combination of your two functions is making your indefinite integral expression over here simpler than the original question expression over here. And in this case, you'll realize that since we are calculating the indefinite integral of x e to the power minus x upon 1 minus x whole square dx, you'll realize that if you take, after going through all the possible combinations, you'll realize that if you take your first function, in this case to be x e to the power minus x, and your second function to be 1 upon 1 minus x to the power whole square, you'll basically simplify this integral expression over here to a much simpler expression than your original integral in this case. So let's do that, but before we go through these choice of functions, I would highly suggest you to try all the possible combinations and check why we chose our first function to be this one and the second function to be this one and not any other choice in order to solve for this indefinite integral over here. And you'll clearly realize that when you'll take the other combinations, those combinations will make your indefinite integral expression complex, much more complex than the original integral expression which is given in the question. So let's try solving this question and see how this simplifies our indefinite integral expression over here. So again, we'll use the same formula, first function as it is, and the integral of second expression minus differentiation of first. So differentiation of first, which is the differentiation of x e to the power minus x, integral of the second, and then integral of this whole expression over here, right? So this is basically using the integration by parts formula. And now since we need the integral of 1 upon 1 minus x to the power whole square dx in two places over here, let's calculate that first. So integral 1 upon 1 minus x whole square dx is simply 1 upon 1 minus x in this case, right? And with the constant of integration, if you're calculating it separately, but since we already have an integral expression over here, we'll not add the constant of integration. So in this case, if we have to plug in the value of integral of 1 upon 1 minus x squared dx, it is basically 1 upon 1 minus x, right? You can also confirm this expression over here. This is basically calculated by using the power rule of integration, or you can also use substitution. You can assume your u function to be 1 minus x, and then your du will become minus dx, and this expression over here will just become 1 upon u square minus du, and then you can use the power rule of integration in order to simplify this indefinite integral over here, right? But the basic idea is integral of 1 upon 1 minus x to the power whole square dx is 1 upon 1 minus x in this case. So now let's take this expression to the next page. So this expression will be simplified to x e to the power minus x. This is basically 1 upon 1 minus x as calculated before, minus the derivative of x e to the power minus x will be calculated by using the chain rule. So first function as it is, differentiation of first function as it is, differentiation of first which is e to the power minus x, and then because of the chain rule the derivative of minus x which would be minus 1. So this would be minus x e to the power minus x, and then plus differentiation of first, the differentiation of x is 1, and the second function as it is. This is basically again calculated by using the chain rule. So first function as it is, derivative of second in this expression, and then the derivative of the first function and the second function as it is, which is over here. And then this expression is basically 1 upon 1 minus x with the dx in this case, which is over here, right? So this integral is 1 upon 1 minus x, and we also have a dx over here which will be added to the integral expression over here, right? So let's calculate this. So this would be x e to the power minus x upon 1 minus x minus, we can take the e to the power minus x common over here, right? So this would be e to the power minus x plus 1 upon 1 minus x dx, right? And now you'll realize why we took our first function to be this one and second function to be this one. That was only because if we do that, we have a 1 minus x term in the numerator, and we also have the same 1 minus x term in the denominator as well. So now we can just simply cancel this 1 minus x with this 1 minus x, and our final integral expression will basically be x e to the power minus x upon 1 minus x minus integral e to the power minus x dx, right? And now you see how simplified this integral expression over here is, right? Because we already know an integral for the exponential function, which is already an exponential function. So this expression is much more simplified than the original integral expression over here, right? So that is why we assumed our first function to be this one and second function to be this one in this question. So now if you calculate the final answer, it would simply be x e to the power minus x upon 1 minus x. The integral of e to the power minus x would be minus e to the power minus x, and since you already have a minus over here, this second expression will turn into plus e to the power minus x. And now since you got rid of all the indefinite integrals, you'll also add a constant of integration at the last. So this would be your final answer to the indefinite integral expression x e to the power minus x upon 1 minus x to the whole square dx in this case. So that's it for this video, but the main takeaway from this video is, again, whenever you have more than two functions in your integral expression and you have to use integration by parts, you'll have to go through all the possible combinations and then notice which combination of your two functions will make your this integral expression over here simpler than the original integral expression over here. Just like in this example, when we took our first function to be this one, the second function to be this one, our integral expression was simplified to basically calculating the integral of an exponential function, right? So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.